Hello, today we're going to talk about how to spread tables and fields among tables. I have been trying to put assignments in these videos, but it occurred to me, it only took week 4 before it dawned on me that having assignments here and on Blackboard is a good example of bad data redundancy. So from now on, find your assignments on the Blackboard, because there's best I can hope for is to keep these two in sync, and that probably won't happen. Okay, starting with week 4, how are we doing? I hope that these terms are clear and you firmly understand them. And at the bottom I'm telling you, if you have questions about these or these aren't clear by now, you need to call me and let's talk some. Data is a single fact that has not been organized into information. A field is a place to store one fact. A record is a group of fields that all deal with data about one thing. So you'd have a employee record, and it would be all the things, the first name, last name, and so forth about that employee. A table is a group of records where a group of records is stored. A file is where we physically store something. Okay, let's check to see how we're doing on the syllabus. We're in 4 weeks now. Okay, we said we were going to define a database and its uses. A database, we know, is a collection of data. A database, its uses, it contains data that is structured in a way that's easy to retrieve. The second thing we said was we were going to describe the difference between traditional files and databases. A traditional files write directly to physical storage. A database management system have a layer of programs that isolate the physical organization of the data from the logical organization of the data. We said we were going to define a database management system, a DBMS, and describe the services the DBMS provides to the users. Okay, a database management system is a collection of programs that enable a user to create and maintain databases and control all access to them. And the primary goal of the database management system is to provide an environment that is both convenient and efficient for users to retrieve and store data. Our fourth thing, identify and describe the main features of hierarchical, network, and relational database models. Okay, we're not there yet. We haven't done that. 5, we were going to demonstrate an understanding of the differences between logical and physical design. Okay, a physical design is when you determine exactly how the data will be physically stored. A logical design is when you lay out the data logically in a database management system, probably, and have no idea how it's physically stored. And I misspelled stored, apologies. Okay, and the 6th point, model a realistic business application using a technologically independent data model. Okay, that's still to come. Alright, the 7th point, design and implement a database using a relational data model with emphasis on data integrity and security. We're still going to do that. Define and use the normalization process to further refine the relational database definitions, still to come. Demonstrate an understanding of the database administration function, that's still to come. And define and be able to use data definition language, data manipulation language, and instructions that apply relational algebra, and we'll still do that. 11, demonstrate the understanding of distributed database systems. We'll still do that. And 12, evaluate and select the appropriate database management system for a given application. Alright, and so we have 12 points. We've covered several of them. And you wouldn't want to finish the whole course in the first 3 weeks, but I just think it's good for us to check back and review where we said we wanted to go and how far we are along the way. Okay. We're getting to where we're going to start designing a database, and I wanted to try to give you a process when you're designing a database. And at least this is the one that I follow. Okay, what facts are needed to solve our stated problem? And so the very first thing, even before you think about designing databases, you have to have a problem statement. We talked about that last week. Okay, how will available data arrive from the real world? This is important so that you can, later we're going to talk about whether you want to have stuff tabulated and summed into bigger groups or whether you want to deal at the detail level. When possible, you need to go to the detail level, but knowing how data is available to you will help you understand the labor required to get it into the database management system, and then be sure that the efforts, the juice is worth the squeeze. How can data fields be grouped together into tables? All right. Embrace detailed data. With computers, we can maintain a lot of detailed data and convert it into information. We talked about Ford Motor Company and where they measured invoices by the foot. That was because of how much effort it took to add the invoices up. Today, if they're in the computer, it's milliseconds. So you want to think at as lowest level of data as you can, because that will give you the ability to analyze it in new ways. Okay, I told you, or if you looked at my resume, you've seen that I used to work in the tobacco industry. The old way when they did it by hand was you accumulated tobacco by grade and by pound. So you knew that you bought 500,000 pounds of B3F tobacco at the home warehouse. You really didn't try to keep up with the different piles that you bought. You just you added it up once and you put it in buckets, and then you moved that bucket around. And if somebody asked you for information about what was in that pile of B3F, how much of it came from one farmer, you couldn't tell. The new way that we came up with was to track by the individual pile or bale. That gave us the ability to do a lot more analysis and to have a lot better inventory control. Tracking inventory. The old way was to track the total quantity of a part in the warehouse, i.e. either that it hadn't been picked off the shelf yet, or maybe it was in the warehouse and hadn't shipped. But you couldn't tell where it was. You just knew that you had 130 widgets out there someplace. The new way is you could track the current location in the warehouse, on the assembly floor, and in the shipping department. Electric bills. The old way was you had a meter that measured how many hours, how much power you used in a month, and once a month somebody came by and read it. They put that number in and billed you for that many kilowatt hours. With the information of things, they know how much power you use each 5-minute period, and so they can bill you different charges at different times of the day because there's different demand at different times of the day. And that Internet of Things type detailed information is spreading all through the economy, and as we get more and more nano devices that are small, it's amazing all the type of data that can be aggregated. But particularly when you're designing a system, you got to consider the labor needed to input the data when you choose how you're going to store the data, because if you decided that you were going to track at some low level for your student project and you don't have that many hours to key the data in, no matter how good your data organization is, your system will die because you can't keep up with the amount of data you need to put into it. Okay, choosing a table for a solution. Okay, we're going to assume that you have at least one problem statement, and we've discussed organizing the data to eliminate redundancy, and it's also called normalizing. But how do you figure out where to put it? Well, let's start by discussing Week 3's Access Database assignment. Why was the video distributor in a separate table? And at this point, I want you to kind of think what you think the reasons are, and I'll tell you why I think they were. Well, we wanted to eliminate the variations of the distributor name. If somebody was all capital letters, Big Dog Distributing, and somebody else was only going to capitalize the first letter, if you had them buried in, if it wasn't a separate table, you'd have two entries and it would be hard to sort. The other thing is it allows the distributor information to be stored in one place. So if you want to keep up with your contact at the video distributor, or their address, or their zip code, their fax number, or whatever, you don't have to scatter it all over the place. You can put all that information about the video distributor in the video distributor table. Okay, just as a point of pride, I would tell you that there's one thing that Access is doing that I'm really not very comfortable with. They have labeled distributor ID here, but they call it distributor name in this diagram. I'd be a whole lot more comfortable, and I'm not sure you can in Access, but I think over time in a big system, and the truth is you can't do a really big system in Access, people are going to get confused with the distributor ID going to distributor. Somebody looks at this and thinks, oh, well, I have distributor name in this title. You don't. It's over here. The link is on distributor ID. So, personal point of opinion, I guess. Okay. I try to think of common pools of data when I'm designing a database. As in, okay, I'm going to have information about a video distributor, so all that ought to be here. I'm going to have information about a title, so that would be here. But because I'm going to have multiple copies, that tells me I got to have a different place to keep up with each copy. And maybe I want to have the purchase date, and maybe even some sort of an accumulator that keeps up with how many times it's been rented out. Although I would advocate against trying to keep those sorts of numbers, because if you're keeping the detailed rentals, you can build that on the fly and it will be a lot more accurate. So think in terms of pools of data and try to figure out which pool a piece goes in. Consider a new table if the field will have the same data in multiple fields. So if you're over here and you find yourself entering distributor name multiple times as you put in different video titles, and you're having to type a long big name, that's kind of an idea that says, maybe I ought to have that all consolidated. And particularly if you have the video distributor's name and the video distributor's telephone number in video title, you'll never keep the telephone numbers uniform. So you want to put the video distributor's telephone number over here. All right, another way to say that is if a field is in multiple rows of a table, has exactly the same data, then you probably need another table, unless there's an exceptional reason. And all broad generalizations are false. Therefore, this is a false statement. So, discussing an enhancement to a week 3 database. They didn't cover this in the lecture, but let's figure out how we would track what employee checked out a rental. Okay. And what if we wanted to keep up with which employee checked the rental in? Well, there's the data structure we have now. Should we add a text field to employee who checked it out to the rental table? So that you type in Bob Smith every time there's a rental that goes out that Bob rents out? Hopefully you all are yelling no, because the text field has the same person entered multiple ways. So you're going to have capital Bob, capital SMIS, Smith. You're going to have Robert Smith. You're going to have B Smith. It's just going to be a disaster. And you're going to have an awful lot of data typed in here. You're going to be carrying Bob Smith around a lot of different times. Okay. So it's hard to sanity check if Bob Smith is an employee. If you put in Albert E. Newman, which you all may not be old enough to remember Mad Magazine, but in my era, I am what is known as a boomer, and Alfred E. Newman was a big fella in our time because he was in Mad Magazine. So a lot of people would enter Alfred E. Newman in things. And if you just got free form text, you can't correct people and say, hey, Alfred E. Newman doesn't work here. Okay. Do we need an employee table, or do we want to add fields to the member table and change its name to individual? So, we could have an employee data out here, but then if Bob Smith checks out things, he'll have to be in the member table, and if Bob Smith is employee, he'll have to be in the employee table. So I lean toward putting him in, changing the members to persons or individuals, and going this way. So we have a individual, and I forgot to change member ID, but you got their last name, and you have the date they joined, and that they started work here, and the date, you have the date they were hired. And in the next example, I'm going to show you that they have the date they left. And one has to be careful when you put in titles on fields, because let's say we say date hired, date terminated. Well, termination has negative connotations, so people may take umbrage to saying, well, I wasn't terminated, I quit. Or, it was the end of the summer, I knew I was going back to college, I don't want it to show that I was terminated. So just a sidelight, you want to think about how you name your field names, because people will care. And then you'd alter the rented table and put in checked out by, and have a lookup over to the individual table. And so you'd get something that looked like this, and notice that it's the same table, but the way it's drawn is that you've got a link going from member name up to member ID, and you've got checked out going down to member ID. Now, it's of interest that this access isn't particularly robust. Just as you can go from state here to get to a state name, you should be able, since it's the same table, to get to here. But Access isn't smart enough to figure that out. Okay, option 2. And why do we want an option 2? Well, the way we've got this now, we have the individual's hire date, but what if Bob Jones works here in his senior year of high school, and then he goes away and he comes back and he works here his freshman summer when he's back from college? Well, when we put in a new hire date, we're going to lose the fact that he's a prior employee, and we probably want to know whether somebody's been here multiple times or not. So what else could we do? Well, we could create a new table called employment history. And so you're going to have your employment ID, which is this time you worked here, and a member ID that gets back to your name and address and so forth, and then a start employment date and an end employment date. And notice we didn't say hire and fire or start and terminate, and we were trying to be politically correct, and as you start designing stuff, you'll need to do that. Now, we could also, in this, make a point of not letting people end their employment before they started their employment. And there's all sorts of validation things like you'd want to do that. So now the rental table would be checked in by and checked out by, and you'd go to an employee number over there, and you could put in a rule that said you can't go to an employment number that doesn't have that hasn't started work but hasn't finished work. So if you worked here last summer and it's December, but you left at the end of the summer season, it would prevent you from going there. Now, the disadvantage of that second solution is if you want to get to employee name, you're going to have to first go to the employment and then use that to go on back to the member to get their last name. I'm convinced that Access can probably do that. The truth is, I haven't worked with it enough to know how to make it do that. If I was in Informix, which is where I spent 26 years, I could do it standing on my head. But those are the kinds of things that you have to consider when you start going multiple layers deep, and the kind of power that you pick up in being able to go multiple layers deep. Okay, neither one is the only correct answer. The world's full of choices, and I do not in any way want to tell you that I'm going to give you this is the only way you can do something. The important is to identify the viable alternatives, weigh the cost and benefit of each, pick one. There's nothing worse than somebody that weighs and weighs and weighs and weighs and weighs, and they think, well, tomorrow they might get better. You've got to, the old thing that the Army said was go left, go right, go ahead, go back, but get out of the road. And so after you've finished weighing them, make a choice, and then be prepared to explain and defend the costs and benefits you expect. Okay. Access has a graphical user interface, and one of the reasons I'm going through all this right now is it's easy to use, but you get isolated from what's really happening. And so I wanted this lecture to try to give you some idea of what's going on behind the scenes, so that it doesn't just feel like you're dragging and dropping and you're not thinking about why you're dragging and dropping. Okay, what does SQL mean? It means structured query language. It's pronounced SQL. It's a domain-specific language. And by that I mean that they will tell you that there's an ANSI standard, and there is, but each brand of database has a little bit different SQL. It's almost the same, but not quite. It's particularly useful for structured data. And if you go to Wikipedia, you can read all about SQL. Okay. How do you read an SQL syntax sheet? Here's an oldie but goodie. Quite frankly, it's Informix, but it's a simple enough statement we get everything on one page. So, if you see square brackets, it means this is an option that you don't have to take. If you see a capital letter word, it is a command to the database, and you have to have create space table. You can say create space temp space table. The command that you actually send in doesn't have to be uppercase. This is just a convention trying to explain to you that create and table are special words, and guess what? You can't have a table called table, because that's like putting an equal sign or a plus sign in a mathematical equation. It's a reserved word. Okay, a lowercase italics means that you need to fill in something, and it's going to be, in place of table-name, you're going to put in customer or whatever it is. And then you're going to have a parentheses, and then you're going to have column names. And you can have multiple column names, which is what this says to you, because again, it's in a square bracket, and so it's optional, and you can have as many of them as you want. So after you say a column name, employee ID, you're going to have a data type, and we'll talk more about data types. And this, what I call a pipe, is really an OR. You're either going to have a data type, which means it's going to be something that is conventional, or this pipe says if you don't have that, then you've got to have either this or that, because a squiggly says one of these is required, and as many different things as our pipes gives you, so you could have 25 things, but you're going to have to pick one of them. So if you're doing what's called the blob, it's either going to be a byte blob or a text blob, and it's going to be in some table, maybe, because that's a square bracket. So the in table is optional, and so you're either going to give it a table name. If you use the word in, you have to give the word table, or because of the pipe, you have to name a blob space. And there's a whole lot more here that I want you to worry about what I'm really trying to get you to understand is, what do square brackets mean? What do squigglies, open squiggly brackets, and I'm sure there's a fancy word for that, and what does a pipe mean? So behind a data type you can have not null, which means you got to have something in this field, but you don't have to have that word because it's in a square bracket. And then you have another thing that you can add that says unique, and you can give a column list, or you can put in a constraint, and we won't talk any more about those here, but then you can have a comma and repeat. And then you have the option at the, you have the option at the end of the table definition to say with no log. And we'll talk about journaling and logs and begin work and end work and so forth, but that's something you can have when you're developing a table, because we've stopped naming the table when we got to this, defining the rows in the table when we got to that close parentheses. You can also tell it in a data space name, and we won't talk much about that, but it's just a point that there's all sorts of ways with database management systems to spread data, not only across disks, but across continents. You can tell how big you want each extent size to be. You can tell when it gets one extent full, how big do you want it to make the other one. You can talk about lock modes, page and row. Again, the point here is not what all these mean, but just how to read it. So what does it look like if you look up the access syntax to create a table? So we have the ability to do an optional because it's in a square bracket. We have a table name like we saw before. We have a field, which is you got to name a field, you got to give it a type. You can do a size, but you don't have to, and so forth. I'm not going to bother you with all of it, but again, the goal here is how do you read SQL syntax and sheets that tell you what the syntax is, because trust me, you do not want to learn all the syntax. There are cheat sheets out there for the database management system you pick, and you may want to memorize all of them, but I would counsel against that too. You have better things to think about. The MySQL create syntax, much the same if you want to compare, but there are little details that are different. Each engine's SQL is slightly different. Yeah, there is an ANSI standard, like I said, and almost all databases claim that they support it. But in each database solution, there are extensions. Oh, well, we figured out how to fill in the blank. And if you want to use all those nifty features, which is the reason you picked the database you picked, your ANSI SQL's going to have problems. So early on, decide the database that you are going to use for your project. What do you consider? You're going to live in that ecosystem. So once you pick the database, you really don't have to, until you change situations, you don't have to go to another one. And I would advocate that you want to try to pick one and keep as much of your data in it as possible. When you go into a situation and you find out, well, somebody's running access in this department, and then somebody's got access in that department, and there's two other departments that run in Excel spreadsheets and keeping the data that way. And yes, we have a DB4, a DB2 database, and somebody else is running Oracle, and somebody's got PeopleSoft. That's when you start getting problems and you can't get the power of your data. So try to live in a single ecosystem if you can. I had the advantage when I went to Stober that there were three of us and we didn't have anything, so we got to pick what we wanted. And we did a pretty good job of keeping everything in the Informix ecosystem. Right before I left, the decision was made to go to SAP, and now almost everything's in the SAP database. And so it's important to stay in an ecosystem. If you've chosen a major software solution, you're committed to that database. you want to optimize for it. Well, and what I'm trying to say is, let's assume that you decide that you're going to use SAP. Well, then you want to find out what database is the vendor that you're buying SAP from most familiar with, and what are they best able to use. Then you better stick with that database and not go, well, we've always liked MySQL if the data system you're using is running on Oracle. Another thing is there's a lot of Windows type software that you can buy, and we bought some calibration software. Well, it was going to run on SQL Server, and there was no reason to think about putting it anyplace else. When you picked that solution, you were going to use SQL Server. MySQL is an open source, read no license fees, and quite frankly, if I had to pick something today, if I was starting from scratch, I'd probably be in MySQL. That's personal opinion. It does not necessarily represent the opinions of management. Other databases have reasons to choose them, and it's a non-trivial choice that you want to give some serious thought to if you get to choose. Many times you'll appear at a work and somebody will tell you, we use fill in the blank, and enjoy, because that's what you're going to use. All right. If you have questions on this, call me. We've covered a lot of stuff. Hopefully it was some of the stimulated thinking. I keep giving out my telephone number and my email address, and I truly look forward to talking to you if you have questions. Thank you again.